I'm going to be talking about how to solve compound and absolute value inequalities. A compound inequality is an inequality joined together with another inequality, such as 13 is less than 3x plus 1 and 3x plus 1 is less than 19. In fact, we can write this as 13 less than 3x plus 1 less than 19. To solve an inequality like this, we first must solve the two inequalities that it's composed of. On the left side, 13 less than 3x plus 1 is going to become 12 less than 3x if we subtract 1 from both sides. Now dividing by 3, we get 4 is less than x. Now if we look at the right side, we have 3x plus 1 is less than 19. If we subtract 1 from both sides of that, we'll have 3x is less than 18. Dividing by 3, we see that x is less than 18 over 3, which is equal to 6. Now, since these two inequalities are joined by an AND statement, the actual values of x that solve it have to satisfy both of the inequalities we got. So we need 4 is less than x, and x is less than 6. A compound inequality can also be made using an OR statement. For example, we could have 2x minus 1 is less than 5, or 4x is greater than x plus 12. As before, to solve an inequality like this, we need to solve both halves of it first. For the left half, we can add 1 to both sides to get 2x is less than 6. Then we can divide both sides by 2 to see that x is less than 3. Now on the right side, we can subtract x from both sides so that we can combine the terms containing x on the left side of the equation to get 3x is greater than 12. Then we can divide both sides by 3 to get x is larger than 4. Unlike before, we do not require that x is less than 3 and x is greater than 4 for it to solve this compound inequality. Instead, since this is an OR statement, we only need that x is less than 3 or x is greater than 4. So if we draw this on a number line, then there will actually be, say this is 3, this is 4, there'll be two disjoint segments where x can lie. And the only values of x that don't solve this inequality are the ones that are between 3 and 4, including 3 and 4. Now let's consider inequalities that have absolute values in them. What if we had an inequality of the form absolute value of x is less than a? This means that x can be negative or positive, but its distance from 0 has to be no larger than a. Another way of putting that is minus a must be less than x, and x must be less than a. It's easy to see that if x violates either half of this inequality, then its absolute value would have to be larger than or equal to a. So these two statements are actually equivalent. On the other hand, if we start with the inequality absolute value x is greater than a, this means that x is further away from a, or further away from 0 than the size a. So either x is larger than a, or x is smaller than minus a. Notice how these inequalities having absolute values in them are really the same as compound inequalities. Because of this, we can solve any inequality with absolute values by moving the absolute value to one side by itself and then turning it into a compound inequality. And we already know how to solve those.